this is Chris with Fun Robotics Network here in the pits with 2052, the KnightKrawlers. They've been doing pretty good. They've got a pretty nice robot. We'll let them show off what they've got.
My name is Kevin. I'm the build captain. I'm also our operator or secondary driver. So coming into the season, we divided our mechanisms into various archetypes. So we understood that we needed a deep climb. We needed some way to score the coral on all 4 levels, and then we needed some way to at least dislodge the algae. So I guess we'll go front to back here. Starting off, this is our climber. A few main points kind of when we were designing this was making sure we were able to grab the cage even though it's spinning, and then also grab the cage at kind of like any angle possible. So understanding that, we decided to only grab one pole of the cage. So one pole of the cage kind of goes here. We align. This kind of post prevents the cage from spinning, and then we go up, and then that's what allows us to climb. So yeah, that's our climber. Going back, this is our coral scorer. So it's kind of like a Rembrandt style intake and then also outtake. And then we have a coaxially driven pivot. So we have a mech spline going through that controls the up and down movement. And then we have a hex shaft going through the mech spline that controls our intake and outtake. So what that allows us to do, it allows us to spin the arm 360 degrees, and also really lowers our center of gravity. So instead of having the motor on the arm itself, the motor comes down here next to the carriage, and that also contributes to our kind of design philosophy of maintaining a low center of gravity. Going back even further, I don't know if you can see this, but we kind of have like a algae arms connected to the first stage of our elevator. It's shaped like our logo, it's shaped like a KnightKrawler. We have this carbon fiber vinyl to make it look cool, but really, this was a way to be able to dislodge the algae, scoring the processor and scoring the net without adding more weight to our pivot. So coming into this, we wanted to keep our pivot lightweight, our elevator relatively lightweight so it could be fast and have a low center of gravity. So by attaching a separate algae mechanism to the first stage of our elevator, it doesn't hinder or prevent our coral scoring. So right now, Caleb is gonna raise up our elevator. Let's go all 3. Yep. So another interesting aspect of our coral scorer is this little alignment pole. We put this on in like week 0 to help with alignment. It's just a post that touches the edge of the reef, and if this kind of bends out of the way, then we know we're aligned. And then, do you want to pull out the algae arm? Sure, go on far. Okay. Yep. Yep. So there's our algae arm moving up and down.
Hello, I'm Isaac. So another feature of this robot is we have a human player intake based on the priorities we established at the beginning of the season. We wanted to have very reliable autos, so we figured we'd prioritize picking up from the human player because it would be very difficult for us to figure out where the coral would land during autos if we were just to throw it down. And if you'll notice, this is just a piece of bent plastic. We found during prototyping that the simplest solution was the best for us. We tried using wheels, but just gravity and a funnel worked best. And then if you notice on all of our mechanisms, we tried to keep them as simple as possible for reliability and also for ease of design. So we have 2 degrees of freedom. We can go up, or 2 degrees of freedom on our coral scoring mechanism. We can go up and we can rotate our arm. We have 1 degree of freedom on our climber, and then 1 degree on or technically 2 on our algae mechanism, because it goes up with our elevator and then it can rotate out. Another feature of our robot is we have these plastic shields. We have a very open belly pan, which is nice for working on electronics, but that also gives a lot of opportunities for coral to get stuck in there and for us to be out for the match. So towards the end of the build season, when we had a more finalized idea of what our robot would look like and we could start working around our mechanisms, we put in various pieces of plastic, like this main one, this side cover, and then we have 2 in the back over here, which also serve as sponsor plastic. And so this enables us to like not get any coral stuck in our robot. And say we miss during a match, it'll just fall down, impact, and bounce off.
Hey, I'm Caleb. I'm the programming captain of Team 2052, and I'll go over some of the vision systems we have. So for vision, we use the April tags to localize on the field. We utilize an orange Pi running photon vision. We have a Arducam 2311 in the front where we score our coral, so that we make sure we have our best pose right when we're right next to the reef. We also have one in the back if we need to align for algae. And something we experimented with this year was putting polarizing lens on top of these cameras to negate some of that glare that we see on the field. And with that, those cameras, we dynamically adjust the standard deviation into our pose estimator based on how far away from the tags we are, how many we see, to make sure we have the best pose on the field.
So very well-rounded robot. You guys have having played a practice day and one match, you guys have any good ideas that you're going to change for your next competition coming up?
Just seeing some like review videos and other robots, I think adding some sort of ground intake to decrease cycle time is something that we could aim towards, and then also combining your algae mechanism into our coral mechanism, so it allows us to pick up algae and score coral at the same time.
Awesome. Thank you for running me through your robot. Thank you for watching. Catch you in the future.